when you have unlocked its mysteries through the language of mathematics. And that's why Sir Isaac Newton was so impressive to people in the 18th century, when with a single equation he was able to account for all the motion in the universe. That was an extraordinarily elegant explanation of a seemingly complicated problem. All the different kinds of motion could be reduced to one equation. And so in the sense in which we're speaking of, he understood the universe because he was able to take disparate phenomena that are all different kinds of motion, but yet account for them all with one simple, elegant mathematical equation. So he is simply bringing to fruition the mission that the Cathedral School of Chartres gave to the scholars and scientists of the West. Now, another problem that was solved in large part by the Cathedral School at Chartres goes all the way back to the ancient world, all the way back to the world of ancient Greece and Rome. Because as far back as that time, people had believed that the heavenly bodies that you see out there were in fact in some way divine. They must have some kind of divine attributes, or perhaps they even have souls in some way, or they were composed of imperishable matter that operated according to laws different from those of our terrestrial world here on Earth. This was taken for granted for many reasons. For instance, in the ancient world, it was taken for granted that a body at rest tends to stay at rest. But a body in motion can only be in motion if something is forcing it into motion. So in other words, the ancient world took for granted that the natural state of things is to be at rest. Motion needs to be accounted for. And yet they look out in the sky and they see the planets are moving, but there's no big hand pushing them. So what's making them move? They should be at rest. What's making them move? So they had to posit all kinds of theories that maybe they have souls and the souls impart motion to them, or they're divine and that accounts for their movement, or later it was proposed that angels might be pushing them. There were all kinds of theories to account for this. But it was taken for granted that there must be different rules governing motion in outer space and governing motion on Earth, because what's going on? Why do they keep on moving? They just couldn't figure it out. These things must be fundamentally different from the things on our Earth. Now, Isaac Newton later showed that in fact the same laws of motion were at work in the heavens and on Earth. That was a breakthrough. But it wasn't something that just came out of left field. Because who really began thinking this for the first time? It was Terry of Chartres, another scholar at the Cathedral School of Chartres in the 12th century. What did Terry say? He said that, in effect, what you have in the universe and in outer space are things that are composed of the same kind of matter that we have here on Earth. Now, he couldn't quite account for why they orbited and why they seemed to move on their own. He hadn't anticipated Newton's laws of motion. But by saying that the stuff out there is in no fundamental way any different from the stuff down here, he has paved the way for a central conclusion of modern science. Now, Thomas Goldstein is a recent historian of the history of science. What does he have to say about the Cathedral School at Chartres? He says, in a period of 15 to 20 years, around the middle of the 12th century, a handful of men were consciously striving to launch the evolution of Western science and undertook every major step that was needed to achieve that end. Goldstein even went so far as to say that someday Terry of Chartres will be viewed as one of the great founders of modern science. Now, can you believe that? There's a historian writing just in this generation. And not only does he credit the church with lending an important impetus to the development of science, but he even goes all the way back to the 12th century to identify somebody nobody's ever heard of and say he may be one of the great architects of modern science. This is becoming absolutely common among historians of science. Yes, Richard Dawkins is writing his books. Daniel Dennett keeps writing his books as scientific atheists. But as historians of science, you consistently get more and more favor shown toward the Catholic Church. Now the question is, how do we get this information to the general public? And as I say, It's not going to get out there unless Catholics start telling it themselves. But that's only the tip of the iceberg, because what we've discussed today is very theoretical. The idea that the universe is orderly, and so on, that it's built according to fixed physical laws. That's all very theoretical. But next time, we're going to get down to the nuts and bolts, because next time we're going to look at how many priests were scientific pioneers. It's not enough to say, oh, look at all these scientists who happen to be Catholic. Well, that could be just a coincidence. They just happen to be Catholic. But when you're talking about priests who occupy such an elevated role in the life of the Church, who have taken holy orders and have that sacred vocation, if they are great practitioners of the sciences and are congratulated by the popes for doing so, then surely the Catholic Church cannot be the enemy of science. So let's look at these great scientific heroes in the Catholic Church next time when we come back once again for the Catholic Church, builder of civilization.